I'm James Davison, a study director at Metabolon and a member of the Discovery and Translational Science team. I am going to provide an example of how Metabolon's global metabolomics platform can elucidate novel mechanisms of host microbiota interactions that may modulate human health and disease. Over the last decade, it has become well appreciated that the intestinal microbiota contribute to host physiology. The microbiota are implicated in several human diseases and disorders in part because disparate microbiota assemblies are associated with different disease states. However, it remains largely unclear if these microbiota assemblies cause the development of many of these diseases. Among the disorders that the intestinal microbiota may influence is metabolic syndrome. This syndrome is the cluster of health conditions that occur together and contribute to the risk of developing heart disease, stroke, and type 2 diabetes. However, molecular mechanisms that mediate microbiota contributions to metabolic syndrome remain unclear. Small molecules and metabolites mediate many signaling events between cells, including inter-kingdom signaling from the microbiota to the host. Therefore, to identify molecular mechanisms that mediate microbiota contributions to metabolic syndrome, Metabolon's global metabolomics platform was employed. In the study authored by Coe et al., metabolomics was performed on portal blood from subjects with type 2 diabetes. In this study, the metabolite imidazole propionate was found elevated in obese subjects with type 2 diabetes compared to obese subjects without type 2 diabetes. Importantly, imidazole propionate is also elevated in conventionally raised mice, but not in germ-free mice. These data demonstrate imidazole propionate biosynthesis may be in part dependent on the presence of a microbiota. Experiments with in vitro human gut simulators demonstrate that the intestinal microbiota from subjects with type 2 diabetes have a higher capacity to synthesize imidazole propionate and therefore may contribute to the increased imidazole propionate levels in portal blood of type 2 diabetes subjects. To test the potential role of imidazole propionate in type 2 diabetes pathogenesis, glucose tolerance tests were performed in mice following imidazole propionate treatment. Both germ-free and conventionally raised mice treated with imidazole propionate exhibit impaired glucose tolerance. These data suggest imidazole propionate may contribute to type 2 diabetes pathogenesis by promoting glucose intolerance. The study concludes with a novel pathway where imidazole propionate may interact with insulin signaling events and activate mTORC1 signaling in the liver cells. By harnessing the power of Metabolon's global metabolomics platform, Coe et al. Established a novel molecular mechanism where a microbiota-derived factor has the capacity to contribute type 2 diabetes pathogenesis.